Hello there, and welcome to this collection of notebooks and tutorials on audio coding. This is a course offered by Professor Schula at the Ilmenau University of Technology. I am Renato, the instructor for these online materials, and on this tutorial we'll continue our talk about filter banks. So let's get started. Previously we've discussed the structure of filter banks, and we've seen our analysis filters, our synthesis filters, we've seen downsampling, upsampling, we talked about critical sampling, and we also talked about the DCT4. Now we are going to talk about modulated filter banks, and we will start looking at extending the DCT. So last time we saw that the DCT4 corresponds to a filter bank with impulse responses for the analysis, here in the time reverse form to simplify the right hand side. And we've seen these equations for impulse responses. So for a subband k and time index n, and they are both in the range from 0 to n minus 1. Now, with the help of a baseband prototype or a window that we'll call h of n, and we see that it's independent of k, we can now rewrite this structure as a modulated filter. So here we have a rectangular window, and we see that it's equal to 1 from n equals to 0 to n minus 1, and 0 elsewhere. And we can rewrite this equation here as a modulated filter, and we have here this window for the baseband prototype times this factor here with the cosine. Now it goes k, it's just here on the left and also inside here. We don't have an index k here for subbands, and it goes from k goes from 0 to n minus 1, but now n can go from minus infinity to infinity. Observe that the window function allows to improve the filter's parameters like stop band attenuation and transition bandwidth, for example.